the model in the simulation program. And also we include some other things like the market penetration, rate change, and also the social interaction. We include this kind of dynamic process in this system. Finally, the referring aspects are listed here, totally 7 aspects. Here, 2010, 2015 are targeted, but this period actually can be extended. And the 7 referring aspects is first the natural change of the social demographics, like people's income, their age, their household size, like this, their employment status. And also the influence of the technology improvement or the rebate policies. And the influence of the soft policies, and influence of land use policy, and the influence of the social interaction, and the change of the market, and also the inefficiency level of the end uses, which decides the lower bound of the energy consumption of each type of end use. So by covering all these aspects, we developed this dynamic simulation program. And totally 6 modules were designed corresponding to the previous 7 aspects. We also designed a simulation interface. From here, you can select the year to implement every type of policy. And also, you can input the parameters which is needed in the simulation. For example, here, if we see a rebate program, here first you can input the policy year, and also, because we don't have data, what type of households will replace their old ones. So we assume there is a coverage rate. Based on Biying's case, it's around 50%, so here we just use 50% here. And also, we don't know how many end uses the household will replace at one time. So we also assume that there is a coverage number for the household. And we don't know which type of end uses the household will replace. That means we don't know their efficiency choice. So we also assume a efficiency improvement rate, which follow a normal distribution. So here you can input their mean value and standard error value here. So based on this kind of assumptions, we run this simulation program. And this program can output any result of the single policies effect as well as package policies. Because we have too much assumptions, so I don't want to introduce a result here, but what I want to say that this kind of system policy is very necessary to see how the package policies can work on the energy saving. And also based on this kind of program, the roadmap of the policies which can help achieve the target, achieve the energy saving target can be output. Because we have many limitations of the data, so we do have some assumptions. The further data we needed is listed here. I think after we collect all this data, we can get a very accurate analysis for the energy policy effect. This talk is a little bit long, so finally I want to conclude today's talk from the policy implication. I think you have noticed that I mentioned the cross-sector analysis a lot of times. So here I want to say again is, no matter for any these policies, actually in my research we do some analysis about all these policies. Today I just show some part. So our result is for any of these policies, we should not only focus on the residential sector or transport sector. We should develop the cross-sector analysis for them. And also, we think that because none of this policy is enough to achieve the FAR target, so the policy system which packages several types of policies should be developed. In other words, the collaboration of the multidisciplinary analysis is needed, like the engineering, economy, the psychological, sociological, this analysis are all needed. So today's talk is finished here, and that's what we want to do. Next step, we want to include the supply side and also economy into the system analysis, and also want to do a large-scale energy system analysis. Finally, I want to say thank you to all of you. First, I want to thank you for Iking, but he's not here because he gave me this opportunity to come here. And also, I want to thank you, Paulo. Also, he's not here. Actually, the project I'm doing here is related to to the shipping efficiency analysis, which is totally different with my own research. So when I came here, I even don't know what is time charter rate, what is DWT, what is fixture. So now I know it. Okay, and I also want to thank you, Nir, Michelle, and Evelina, and Andres, and Hannah, and also a lot of people who gave me their valuable time to talk with me. And I really benefit a lot from those talks. And finally, I want to thank you for the whole transport group. Because of you, my life is very interesting here. Okay, really, thank you very much. This is a laboratory I'm staying in Japan. We also have some funny life there. We are a big family which have more than 13 members coming from different countries. So, and we always organize such kind of barbecue or sports parties together. And as for the research topics, the topic is very wide. We look at people's quality of life by considering the city planning. We look at the transportation by looking at the behavior, the safety, their ITS, their QOD. And analysis. We also look at environment, energy, and also tourism behaviors. So if you have interest with research and also with life, they're welcome to visit us. Okay, thank you, finally. Thank you very much, and welcome your comments and questions. Okay?
Thank you very much for that talk. I was just sort of wondering, the term self-selection that you used in a way that I'm not at all familiar with from the sort of social science literature, and I didn't know whether there's some distinct differences in China or Japan in terms of how the terminology is used and what is considered to be a self-selection. Do you want to talk a bit more about that?
Yeah, actually for the self-selection, because those kind of unobserved factors, it's very difficult to get it from the survey, right? So we use a model here. And the self-selection is represented by using some random arrow terms in the model. Okay. Here we use unobserved random components to represent the self-selection, which work on both the location choice and the energy consumption behavior. It's actually a group for those kind of unobserved factors which influence people's like the location choice and also energy consumption behavior. Because here we only use Beijing as an empirical analysis, so we have no idea whether it's the result of the other countries or other regions. But we think that because this kind of unobserved factors actually it changes. We think it changes across different regions and across different countries. So it should be some country specific or region specific. So I think this kind of analysis, if you want to capture the UK's case, you better develop your own models and based on your own data, and then you can see it, look at it more clearly. Yeah.
Thanks. It's actually a very interesting work, and it's much interesting and maybe difficult than what we are doing. I have two questions. When you talk about this household energy consumption, especially for transport, for most of the developed country cities, car is the prime transport actually in terms of private transport. Yeah. But for some developing country cities, especially in Asia, two-wheeler actually consume large amount of energy. But it has not been included here, especially in some Asian cities. When the income rise, people normally shift from public transport immediately to two-wheelers, not to cars. So it may not actually accurately kind of capture the change in energy consumption. The second thing is self-style change or something? Self-selection. So how do you deal this one with country like Bangladesh, Are you still thinking darker people will kind of self-selected for changing their lifestyle, thinking environment or climate change or something?
So are you from Dhaka?
No.
Oh, okay. Yeah, okay, I'll first answer your first question. Yeah, here, actually, yeah, we didn't look at some like the motorcycle, those another vehicles. We just look at the cars because here we target as Beijing's case. And actually, we have done some comparative analysis between Dhaka, in Jakarta, and Beijing and Tokyo. We find that Beijing actually is they follow a Kuznets curve. So it's like this way, and Tokyo is here, and Beijing is here, Jakarta and Dhaka is here. So we think Beijing might be a sample for the Jakarta and Dhaka. So that's why we choose Beijing as a context to do this analysis. But so in Beijing, actually, in Beijing we don't have a lot of two-wheels vehicles. That's why we didn't consider that. We do ask the information like the motorcycle or the electric bike information in their household. In our questionnaire, we do have this kind of information, but we just didn't analyze it here. And for the Jakarta's case, we also analyzed how the motorcycle, like ownership usage, interacted with the car and also other domestic appliances. We do find some relation between them. So we think that for the less developing countries, we better look at this kind of other transport modes in this system analysis. But for the developed country, yes, it's true. It's like a car-dependent country. So that's why I also mentioned this is energy consumption behavior analysis looking at the developing countries. For the developed countries, I think the case is also different again. And for your second question, self-selection, right?
Yeah.
What's the question? Sorry.
So is it an issue for country like Bangladesh or Dhaka?
Yeah. Well, we did the self-selection analysis for Dhaka and for Jakarta. We find that the self-selection in this, the self-selection effect actually is decreasing with the economy development level, which means like because for Tokyo the economy development is the highest, so there's a self-selection effect actually is least. While for Dhaka, it's the largest because in the population, most people they don't have this kind of very high environmental awareness because at this stage maybe the money plays more important role. We also find that their income level do explain the largest proportion for their energy consumption behaviors. But we need to consider this kind of variance in the population, and also the self-selection actually is not only this kind of environmental awareness. They also have their preference, their the attitude, and also their the identity. For the poor people, maybe for the rich people, especially in the developing countries, the identity issue is much more important for them. So we group all these things into the self-selection effect. Then, because we cannot capture them based on the questionnaire survey or based on just ask them, so we have to use the model to find out this kind of group influence from these unobserved factors. So, is it okay?
Yeah.
Thank you.
How did you measure energy consumption in the surveys in the homes?
Yeah, we first asked the efficiency of the appliances, the power, the energy intensity for the appliances, and then we asked them how many hours they will use per day, like per weekday or per weekend. And because in Beijing we don't have this kind of peak or off-peak prices, different prices. So the price is constant when I did this survey. So we don't consider this kind of peak or off-peak information. We just look at how many hours they use per weekday and per weekend. And based on their usage information as well as the intensity information, then we calculate their energy consumption.
So did you actually measure the energy consumption of the homes?
Yeah, we asked them how much electricity, how much gas, how much gasoline they use per month. We also did some analysis to see the electricity and the gas and the gasoline, whether they have some influence. We also find this kind of influence.
Okay, so do you think people in the homes would know how much energy their washing machines used?
Yeah, they don't know, I think.
They don't know.
Yeah.
And yet you think that if you halved, if you doubled the efficiency, they would spend twice as much time washing clothes.
No, actually we don't.
Isn't that sorry, I must have misunderstood. I thought there was 100% rebound on washing machines.
Yeah, that's the result shows like this.
Yeah.
You see?
So do you actually believe that if you gave somebody a washing machine that was twice as efficient, they would spend twice as much time washing clothes?
Because now I think in developing countries, because a lot of people, first is saturation, the penetration of the clothes washer is not so high as the developed countries. So they can choose to buy a new clothes washer. So this is the first way for the rebound. And secondly is their usage, because now a lot of people still use like hand clothing, hand washing. So in this case, if this is much more efficient, then they can change to use the clothes washer to wash. So that means the demand is increasing. Maybe it's not just because their time is increasing, their frequency can also be increasing, I think. It's like this. So this result, I think, is understandable for the developing countries. But for the developed countries, maybe if we get this result, then it's very strange, I think.
So it is something due to the increased level of ownership, the energy consumption increases rather than
Because we also consider the ownership in the model, so we can also capture if something changed, then how their ownership will change, and then also the usage change.
Can I ask you a question on your policy package? I mean, I'm struck looking at these Asian cities that if they're characterized by people behaving due to things like status and not environment, and that their price elasticities are almost zero, and their rebound effects are fantastically high. Is there fundamental limits to policy? I mean, in other words, is energy use and emissions in these huge growth cities and economies just going to keep on going up and up and up? Because you said China has these very ambitious targets. Based on your data, I think those targets are completely unrealistic.
Because I also look at some other report from China's case. Our target is 45%, but this target is total. And for the household sector, for the electricity part, the final target is 7%. They actually divide this target into several small parts. So for the electricity part is 7%, while for the transportation part is around 15%, especially for Beijing's case. They divide this target into different region and different sector. So if we look at this target and also compare it with package policy system analysis, then we find that because based on the simulation result, I find for the package analysis, actually it can achieve 2% to 15% energy reduction. So if this, then we think this kind of target is available. It's possible for us to achieve those targets. Is that your question? Sorry.
Well, if I would think that it's more likely that energy use will be enormously higher rather than even stabilize or go down, based on the characteristics of the population that you've described.
That's true. I think because in that model, actually, we include like the income, we include like the income level, like the household structure, and also like the employment situation, and also the children's preference present. Include these variables in that also simulation program. So if some population characteristics change, like the income level, then we can be represented. It can be represented in that system model. Or if you want to know other change for the population, then you can also include other variables in the model. Then you can also see how those things change, influence the final energy demand, and also influence the effect of the energy system models. Because here we only have the cross-sector, we only have 1 year's data. So for the price, we don't consider it, and we don't know how the price influences the energy demand. But if we have more years data, then we can see how this kind of price change influence people's energy demand. Okay, thank you. Any other questions, comments?
Well, if we don't have any more questions, you can just join me in thanking our speaker once more.
Thank